Hello guys, let's simplify differentiation. Let's explain it to the layman so that the layman can understand what we mean when we say differentiation. So let's go. As we know, the general formula for differentiation of the function y equals to s raised power of n is given as dy ds equals to nas raised power na minus 1. What it simply means, if I say differentiate y equals to s raised power 5, for instance, you just tell me that dy over dx is given as, so if I apply this formula here now, it means any come down, which is 5 coming down, s raised to power of n minus 1, and here is 5, 5 minus 1. This will give you 5 s raised to power of 4. So let's take a look and see the different derivatives that we should have at our fingertips, so it will make this journey easier. Follow me, let's go. So welcome back. These are the different derivatives, what we get when we differentiate some of the common terms we know. So here you have that when we differentiate s raised by n, like I said previously, you have n s raised by n minus 1. So if you differentiate a constant c, you get 0. So if I say differentiate 5, the answer is going to be 0. If you differentiate 1 million, the answer will be what? 0. That is what it means. Whatever constant you differentiate, as long as it does not have any variable to it, the answer is 0. So if you differentiate a s raised by n, that is a constant that is multiplying x value, for instance 3s cube. So the 3 will come down to multiply 3. You have 3 times 3, s raised power of 3 minus 1, which will give you 9s squared. So that's what this one means. So if you differentiate sin s, you get cos s. Differentiate cos s, you get minus sin s. And the same way, if you differentiate tan s, you get sec squared s. Then if you differentiate exponential of x, exponent of s, you get the same thing as e raised to power of x. That's the same thing. So having said this, we're going to also look at some other formula we use also. We'll talk about the product rule, the chain rule, and the quotient rule. So let's take a look at them. So we have product rule here. You see, if y is uv, so you are given y to be uv, this u can be, the u means the first function, v is the second function, maybe they are multiplying themselves, you are asked to differentiate it. The general formula to do that is given as dy ds is equals to u dv ds, that is u dv ds plus v du ds. So simply put, how we used to remember it those days was you say put down the first, differentiate the second, plus put down the second, differentiate the first. That's an easy way to remember this. So for instance, if I say I give you y is equals to maybe s squared cos x. In this case now, the first one is s squared, that is u is s squared, then v is the cos s. So here now I put u, which is s squared, I differentiate cos s, giving me minus sin s. So the same thing plus I put the second, which is cos x, I differentiate the first, which is what? S squared. So whatever you get here is your answer, as simple as that. In the same vein, what you have here is quotient rule. When you have y equals u over v, instead of multiplication, it is now division. So this dy ds is given as v du ds minus u dv ds all over v square. In the same way, you can say put down the second, differentiate the first, minus put down the first, differentiate the second, all over the second squared. So as simple as that. So guys, familiarize yourself with these formulas. We shall be using them as we solve problems. Let's look at the chain rule and see what it has to say. So guys, for the chain rule, so there are certain functions you will be given, it becomes somehow confusing, how you're going to differentiate it. For instance, if you're given that y is equals to sine 5x plus 3. So if you look at here now, you find that y is a function of this angle 5x plus 3, which itself is a function of the value of x. So you have two functions inside one function. So to differentiate something like this becomes a bit confusing. So there is a way we go about it. So how do we go about it to make it easier? So how we do this is we say, okay, we put 1 to be u. We say put put this 5x plus 3 to be what? U. So if you say let 5x plus 3 be U, it implies therefore that y is equal to what? Sine U. So if you do this way now, it makes it easier for you. You can get the U ds and at the same time get dy du. If u now is equals to 5x plus 3, we can get du ds, which is du ds can give us differentiate this thing. This one becomes 0 because it's a constant. Differentiate 5s becomes 5. So this one gives us 5. You can also say also y being sine u, dy du can be given as a cos what? U. So you see, it makes it easier. So that takes you to what the formula says. So chain rule says that if y is equals to a function like this, that dy over dx is given as dy du times du ds. Remember, in differentiation, most times we use dot to denote multiplication because of to avoid confusion with s. Some people get confused when you write x and multiplication sign. So anytime you see dot in differentiation, it simply means multiplication. So this is what we use to differentiate such functions. So in this case now, if you apply this now, it means the y du times the u ds. So our dy du is what? Cos u, times the u ds, which is what? 5. This gives you 5 cos u. But remember, we said u is equal to what? 5s plus 3. So in that case, if you replace what the value of u is, it means that dy ds is giving us 5 cos 5s plus 3. So this is the value for that, the answer for that. So that is what we do in general. And then, having introduced this a preliminary concept, we last sit back while we deal with questions coming from differentiations. I promise it's gonna be fun, guys. Follow me, let's ride along. Thank you. See you on the next video.